Hope you enjoyed my last video on the mechanical build of this FORTIS CNC machine. In this video, it's gonna be a little bit different. Now that I've built the machine, what I gotta do now is run all the wiring through and show you how to basically set up the whole electrical build. As you know from the mechanical build of this CNC machine, it's not a typical CNC machine that you would buy already pre-done, just plug and play. We've got all the wiring all here just in looms like this. So you've actually got to cut, drip, twist, crimp, solder, a lot of it yourself, which I've really enjoyed doing because it's kind of, I'm learning a lot through the process of actually building this machine up. And with this video and the excellent instructions that this machine comes with, it's not that hard. So let's run through it today and I'll show you a little bit about how to do the electrical wiring on the FORTIS CNC machine. So with this machine, you've got a bunch of different little controllers that you'll have to all connect together with all the wiring. You've got your motion control system. This is actually made by MakerStore. And from what I've been told, this is like really cutting edge technology. You've all your drivers, you've got your power supply units, all that stuff. So the first step in actually doing this electrical build is actually making some sort of computer box to actually house all these things in. Because in an environment inside a workshop with lots of dust, you do kind of want to keep the dust off a lot of these things. You don't have to, but it's just a bit of extra security, making sure that all your components will last a long time. There's a couple of ways you can go about this. You can go to MakerStore and buy your own enclosure box. They actually do sell them. You can also buy one from Bunnings or any other sort of store that you can think of. Even computer stores might have those enclosure boxes with built-in fans already. I've decided to make my own one. Okay, I'm just gonna custom box here. It's probably not ideal that I'm doing it with wood or MDF, but I am for fire risk, but I don't think I'll have any issues with the fire here. What I've done here is I've just cut a board of MDF. Now the first step is kind of laying everything out and sort of looking at the instruction manual and deciding where you want to lay them out and screw them to your board or inside your enclosure box. Now I've done this in a certain way because I'm trying to minimize the length of all the wiring that has to go back to this controller box here. This E5 MCS controller box takes everything. So everything's got to run through that. This is basically the brains of your machine. So I've set it up like this. I've got a little 100mm fan that I'm going to add in later, and that's going to kind of keep the heat out of this little enclosure box. This is just the board right now, but what I am going to do eventually is kind of screw some sides onto this and make it into a box. I put a little door in the front and mount that under my table. So I've already mounted all these on there. You've got your 2 power supplies here, your 4 stepper motor drivers, and your control unit. So let's now go ahead and I'm gonna run through how to wire all this up and get this mounted to the bottom of the table. All right, so the first step is kind of figuring out your connectors and your crimping or soldering method. So here's the fork connectors that I've had to go buy for my power supply units. These work really good because you can unscrew the screw on top, slide these in and screw it back down with your wire coming out the back there. It's a really good way of doing connections. So I'm just going to show you 2 different methods of how to do this, one with solder and one without. So I'm just going to strip this wire open now, and you've got 2 ends here, and you can just strip these ones off as well. Now, if I was going to use just the soldering method, what I would do is I would actually pull off this this blue cap here. I'm just going to try my best to kind of grab that, just wiggle that off, get rid of that. So now what I have left is my fork connector with that little bit for the wire at the bottom there. Now I'll leave the other one on, and we'll do this one first. So how these ones work is you've got to screw, twist your wires together really well after you can then poke this through into your connector like that. You can see it just coming through the end there, which is fine. Then going to get your crimpers and you're going to crimp them on. Okay, like that. So that's one method, and that's pretty good. Sometimes they can pull out if you give them a really big tug. That's one way of doing it, and that works pretty good. I'd also chuck some heat shrink over this just to make it look a bit nicer. But another way of doing it, and the way that I kind of prefer, I bet you some people in the comments are going to say this is probably not ideal, but I'll show you anyway. Pop over my fork connector like this. I'm now going to pop over here in my helping hand, and then with the solder, just going to apply enough solder to cover that wire, really give that connection to the fork connector. I've just let that cool down now, so I can take that out. Put our 2 different options there, and the next thing to do now is just to apply a bit of a heat shrink to both of them. We can now heat that down, bring that heat shrink in, and there's 2 ways of doing it. I'm always going to choose this soldered option for these connectors, and the next ones I'll show you, I actually think differently. So let's heat those down and I'll show you the next step. Cannot find a lighter or my heat gun anywhere, so I'm just trying to, all right, here's the 2 wires all heat shrinked up, ready to go. You guys decide what option you want to go with. If you haven't got a soldering iron, you'd probably just stick to the crimping method. If you do, you might try this other one, but it's completely up to you. Whatever you feel comfortable with and whatever you think is going to create the best conductivity through your cables. Now the next step, you don't actually need your soldering iron for this one, but this is the second type of crimping that you might need to do. And this is actually called ferrule. I think they're pronounced ferrule crimps. And you know, a lot of people also refer to them as bootlaces, but basically how they work, okay, so you've got a round part at the back that you'll actually put the wire into. You'll bring the wire right through to the end, and then you'll actually crimp it with a special crimping tool. You've got all different sizes of these. You've got tiny little ones like this white one here, or you've got slightly bigger ones like this red one, and the color actually determines what size end you have. So you can see there that the white one's slightly smaller than the red, but there's blue, there's pink, there's yellow, there's all types of ones. But for this build, I think white and red are the best. So what you're gonna do, get your wire, you're gonna strip it off to about the same size, the end. Now I've done some research on these bootlaces here, these ferrule. Okay, this is a bit of a controversial topic, but like swear thick and thin that you twist your wires after you've stripped before you put it on. And most of the research I did online said do not twist, just poke it on, crimp it down, and that gets the best connection. To do the crimp, and it should spring back open at the end, put it through the hole, okay, right up to the end, crimp down, give it a good squeeze and remove. And as you can see, if there's any sticking at the end, I like to get my little side cutters and just give that a bit of a clean. Now these ones are actually designed to go in these can, as you can see, you unscrew the little screw on top, which opens up the mouth, and then you can poke these in. I've made up these cables here. We've got our forks on one end and our ferrules on the other end. These are going to go power supply here. Now, because we're wiring two different power supplies into one control box here, we actually need to link these up. So what the instructions say to do is connect the voltage negative on this 36 volt power supply over here to our dual power supply, and to connect just this black wire here into the other black wire on this other box over here. So I'm just going to pull that one out, hold these two forks together, and just kind of poke them through and screw them down together just to link them up. Perfect, screw that down. Now our controller box has power from these two power supplies. We've got a 36 volt here. This is a dual power supply. This one puts out 5 and 24. So all up we have 5 volts, 24 volts and 36 volts, all coming into these different little components here. All right, now I've got power to this control box here. The next part is to connect these 4 stepper drivers to the control box so that we can start controlling them on the machine. So if you look over here, this machine has 4 different stepper motor drivers. There's one there, there's one on the head, there's one on the other side, there's one on the other side there. So now we've got to connect all those into these drivers here. Now to do so, we need to use some dual core wire. All right, so I've just cut this to length here. I've got a white and a blue on either side. Now the white going into PUL plus, I'm just going to poke in there, and the blue's going into DIR plus, and go into DIR and ST. So like I said, the instructions are so easy to follow at this stage. Had no issues. The hardest part is just cutting your wire the right length and then putting those connectors on. So that's this one done. I'm now going to work across and get all 4 of those. Now it is important to mention here that these 3 stepper motors are running the X-axis, the Y-axis and the Z-axis. Now we have another stepper motor on the other side of the machine, which is basically doing the exact same thing as the other Y-axis. So what we want to do here is plug this one into what's called clone. And clone on the motion controller box basically means it's going to clone whatever the Y-axis is doing. So we're going to plug this one into clone and make sure we don't make the mistake. For this next step, I've got these 4 drivers that I have to connect this green part here to. So I'm going to connect the driver straight to this side. I'm then going to connect the other wiring to this side, and then that can run all the way back to the motion control box up on that board that you just saw. So what I'm thinking of doing is just kind of wrapping this around here, stripping, putting my ferrule clamps on, and then just sort of zip tying that, kind of just zip tying this to the actual driver itself, and then I can run the wiring off that, plug it in, and that can go all the way back to the control box. Now, just looking at the instructions, the actual order I need these in is red, green, yellow, blue, I believe. Sorry, red, green, blue, yellow is what we want. All in at the same time. There you go, have a look at that, perfect. Now, ideally, just to make everything look kind of neat, I'll tie it around like that and just sit that on top of there like that, chuck a zip tie around it, and the other end, hopefully just plug into that like this, into our cable chain and all the way back to the controller. Now, I have to do what you just saw me then for the other 3 drivers, and then I've got to do it on the other end of the wire to go on this side. So I've got another 4, 8, 16, 24, 32 more crimps, ferrule clamps I've got to put on. So what I've got to do now is connect up these 4 stepper motors back to the stepper drivers on that board you just saw. So I've got this thick 4-core shielded cable here. There's a fair few meters of it. I'm going to start running it up the drag chain to each motor, cutting it off and then doing that 4 times. Hopefully there's enough cable here to get through all of them. And basically once I wire it up on the other end with those little ferrule connectors, I can then bring all the other ends back into that board and connect it up to the drivers. Surely there's an easier way of doing this. There's probably people laughing at me in the comments, but this is kind of tricky to get this right through the drag chain and over. If there's an easier way, can someone please tell me in the comments how to run these wires in? Because I've got to run like 8 or 9 wires through this. So I've got one through. Down through this back one here. And I want to go over to the furthest motor first. All right, I've just ran this one through the bottom of the drag chain and I've actually come out the bottom here. I think that'll be okay. And this one will come over to this stepper motor over here. Now, if I drag this axis to gantry and all that here, it doesn't really affect the bottom there. And as I go all the way back, it's still okay. So I'm probably gonna zip tie this to the rail, come around this corner and attach it into here. So that's that one done. Now the next question is, where am I actually gonna bring this down? Am I gonna bring it down over the front? Am I gonna bring it around the side of the table? Am I just gonna bore a hole in this bench and run all the wires through the hole? I don't know. I think the easiest way would probably be, the nicest looking way would probably be to do a hole and bring all the wires down through that. I don't really wanna drill a hole through this bench though. So maybe I'll bring them around the side like this into the back of that big board that'll sit at the front here. I don't know. If I do bring them around the side, I can always drill a hole later and put it in there. So I might do that for now. Now I need to give myself enough slack before I cut it to run the next one. Enough slack to get into the back of this board and into my stepper driver. Now with this motor up here, I've pulled enough through so I can just get to it here. And this is the clip that we put on over here. Now I've got to put the other clip on this end, push it in together. And because there's enough slack on this, I might actually push it back into the drag chain to hide it. So you won't see this clip and anything, untidy. It'll all be tucked back in there. So that's probably enough pulled through there. Now I can get the other end, pull enough back through and chop it off with the snips. And then I can run the last 2 motors. Check this out. I just ran the last wire through. Look how much was left over on that last one. So the amount that I left and cut off each run, so I've got 4 lengths here that I'm gonna wrap around this leg and tie in to the back of that. Now, before I move on any further, what I'm gonna do now is I'm just gonna tidy up the wiring inside this drag chain. I think this is a pretty important step because there's gonna be more wiring running through it. It's all kind of twisted and overlapped at the minute. What I'm gonna try and do is sort of tease it all and get it all running side by side to each other. This might take a while, but I think it's gonna be an important step in the long run. So get it all nice and neat, running side by side. You might need to unravel it a few times and twist it on either end where it's hanging out, but get it all nice, and I think it's gonna pay off in the future. All right, so bit of an issue here. These are the cables here that I need to connect into this. These ones coming off the motors actually have colors. So we've got a yellow, blue, green, and red wire. But this 4-core wire here doesn't actually have colors. It just has 2 blacks and 2 whites. Now what I've decided to do is just make sure I remember which black or white wire went with which color and do the same on the other end, and it should work. So for example, if I go white 1 with yellow, white 2 with blue, black 1 with green, black 2 with red, write that down somewhere and copy it on both ends on all the motors and all the drivers. It should all connect up and be fine. This big thick cable here that I've just ran through the drag chain is basically the middleman between the 2 ends. I've done that with all these now, but haven't left myself enough room to actually see the labeling of each one of these colors. So I'm gonna have to cut a little bit more insulation off this, which is annoying, to actually see, otherwise I'm gonna make a mistake. All right, so what I'm gonna do now is just unscrew this little green connector, and I've got to make sure I line everything up right. So I've made a little card here. Red is white 1, green is white 2, blue is black 1, yellow is black 2. Red will be white 1, green white 2. Poke them all in, tighten them down. This is the fun part, to just go, boom, done. That's one motor. Done. Just to clean it up a little bit is actually tuck this one back in. This was my idea from the start. So I want that one to run down there. So now this green clip is actually inside the drag chain. Okay, I've done the 4 motors now. This is all ran. Obviously I haven't fixed it up on the other end. What I'm gonna do now, grab this smaller wire. This is still shielded 3-core wire. I'm gonna run 4 lengths through just like I did then. This is actually gonna connect up to all of the limit switches. There's 4 limit switches similar to the motors. So I'm gonna do that now. Same thing, ferrule clamps and the green connectors, connect it all up. I'm gonna leave all the wiring out this end and we can connect all that to the board at a later time. Okay, now I thought it would be a good time to actually bolt this CNC to my actual tabletop, because currently it's not actually bolted down. Maker Store provides you with these corner double gusset aluminium brackets, I guess you could call them, and they actually bolt onto these 4 black corner pieces that actually attach to the CNC machine. So there's a few different options. What I'm gonna do, I'm gonna bolt them onto the sides of these brackets and actually just screw them down to my tabletop. But as you come over to the other side, you'll notice that it's kind of impossible to do it from this side over here because the drag chain sort of sits here. So on this side of the machine, we're gonna mount them underneath like this, and I'm gonna probably have to mark them, slide the machine over, drill the gusset to the tabletop, slide it back, and then bolt it to the machine. And on the other side, I can do that at the end and just screw it straight down because there's no drag chain on the other side. All right, so I've just bolted this bracket on here temporarily, and I've just cut up a little small pencil. Just going to mark those 2 holes, move the machine out of the way, fix the bracket to the table, move it back, bolt it on. That's how I'm gonna do this side, and then on the other side, it's gonna be easy. All right, that's all fixed down to the table. Rocking it back and forth, it does not move a millimeter. So that is nice and ready to move on to the next step. All right, obviously this CNC is water cooled. So now there's time to put this pipe through, this polyurethane orange pipe. Now it's currently in just one big long pipe. What I'm thinking of doing is just finding the middle point, cutting that, and then taping it together and running it through as 2. I just feel like, why do something twice when I can just do it once? See if that pays off. You've got no idea how excited I am about this step here. This is the last electronic wire I need to run through this machine. This one's going straight to the spindle and then straight back to the controller. So let's get this last one in. At this stage, everything that side of the machine is pretty much hooked up. I've just got this water cable and spindle connection to go on, but right now I've got to get ready to tackle this. So have a look at all these wires. This is some crazy amount of cable here. This is all going to be tucked underneath the bench like this, and then all sort of connected in to the controller board like this. So I wish I had something. I probably could cut and notch a little part of the table out, but I don't mind the look of the cables just sort of bending around that bench bit there. I feel like I'm finally getting somewhere. This part here has taken me a while, only because I'm really taking it slow, taking my time. The little crimps and little ferrule clamps and all that sort of thing I had to do, all the soldering, the cable management. I'm a bit of a weirdo. I kind of like the cable management. I don't know why, it sort of soothes me a little bit. I also did contact Maker Store a few times throughout this process just to get a bit of help with the engineers. Had a few questions about things, but they were quickly able to answer all the questions I had. Let's get on to the next step. I'm up to doing the enclosure box now. I'm going to show you that in a minute. Basically, I've got to cut up the sides of the box and actually glue and nail this all together. So this is kind of what we're up to here. I'm going to put a piece across this side and both long sides, nail it all together to make a bit of a box. And then I'm going to make a door later with like a clear plexiglass on the front with a hinge so I can swing that open and access this area when I need to. But the clear front will allow me to see through it at all times, and with the addition of a few fans in certain spots. Now just making up a little door for this unit here. I'm just going to make up a little frame out of some pine like this. The frame. This will be the frame for the door, and I'll dowel all this together, glue it all up so it fits. And then inside here, I'm actually going to route and rebate in some clear plexiglass just so I can see what's going on in here, make sure everything's all good. This area here, I probably don't need to access that often. This has kind of got just your drivers and everything in it. But the other box, I'm going to do a similar frame, and that one is the one that I'm going to cut a little hole out to touch the VFD. Now this door here, I'm actually going to have on a hinge. So I'm going to put 2 hinges at the bottom and access it like this, open and closed. So that's just what I'm doing, but there's a million different ways you could build your enclosures, different materials you could use. I'm doing this because I like wood, so. I purchased some of this 3mm clear plastic acrylic, I guess you could call it. What I'm going to do now, I've got my router here. I don't know if you can see that on the camera, but I've put this little rebate bit in with the ball bearing on the top. So I've set this to exactly 3mm because the plastic is 3mm, and I've got this little bit of 3mm ply that I've just checked the depth with. So it should be sweet. I'm now going to run around the inside of this frame and the other one. And then I can take this over to the table saw, cut this, and actually sit it in there. I might screw it in or glue it in. I don't know what I'm going to do, but that's going to act as the glass door for the front of the enclosure. There you go. All done. Got to now attempt these hinges. So what I'm going to do is just remove this door for now. And I've just got these little black easy fit hinges here. These ones you don't really need to chisel in or rebate in. So just going to chuck one, say 100mm from the edge. So if I mark 100mm there, 100mm back the other way. And hopefully we bring this down. Now the fans I'm using for these enclosures are these 80mm fans here. These are 12 volt 1 amp fans. I also bought this little kind of grill to go on top, stop any chips and stuff getting in there. Now I've just tested this with a 76mm hole saw bit, and that seemed to work pretty good in this little offcut of chipboard here, and that worked really well. Just covers the inside of the fan area there. So I'm going to install these in the boxes now, see how they go in. So this one here actually flows air into the box, and the one at the top that you probably can't see out of screen over here blows the air out of the box. Got cool air coming from the bottom and hot air coming from the top. That's what we look like from the back there. All right, this first enclosure is completely done now. I've just got to fit it to the machine, but let's just have a look at what I've just done here. So doors open here. I've got my 2 fans. This is my intake. This is my exhaust one here. Stepper motors down the bottom here. Dual power supply, single power supply, and of course, motion control system that MakerStore actually developed themselves is up here. Most of my wiring is done. I've still got to bring all the wires from the machine through, connected to each stepper motor and up to the control system, but pretty much that is basically it. I'm happy I installed 2 fans. I was only going to do 1 fan and just have the heat like come out of the box, but after doing a bit of reading and a bit of ChatGPT, it's good to bring some air in, some cool air in at the bottom, hot air rises, and then it pushes it out at the top. So all in all, I'm pretty happy with how this turned out. Now I'm going to whip up a quick enclosure for this VFD. All right, so I've just finished off this box here for the VFD. So I've got this base board in here where the actual VFD is going to sit, so that'll go inside like that. I've made it so it's going to sit flush with the front there. I'm going to make like a glass, or not glass, but plastic panel, clear plastic panel on here, and I'm going to cut out this little square here so I can still use the controls to control this unit, but I still want it all sealed. And then at the bottom here, I'm going to have a little exhaust fan. At the top here, I'm going to have exhaust fan, one bringing air in, one pushing air out. So that's basically ready. All four corners are done. Let's check the fit. Beautiful. All right, so I just got to cut this little square out here. When this door goes over the VFD controller, I can still access the buttons, but it's still going to be sealed and dust free. So I've drilled 4 holes and I'm going to hit this with the jigsaw. Kind of think this is not going to work. I've got a feeling the jigsaw might be too aggressive and it might actually crack the plastic. All right, that actually worked out pretty perfect. If I was being pedantic, I'd probably run the file around it, but I think it's actually not too bad. I might do it a little bit at the top. Let's just try and fit this in. That has really surprised me how good that is. Everything's sealed inside the box and we've still got our exhaust system at the bottom. It's time to now get these 2 boxes under the bench, screwed down and screwed into each other so I can move on to the last final part of the wiring. There's only one way these all go in. I've got to put this one in first on an angle, then I've got to slide this one in on an angle. So it's all made pretty tight. I'm excited to get these in. Let's go. Look at how good that looks. That is so good. I actually feel like I've outdone myself. I think some LED lights in here and here. So just some cheap 5-volt LED lights. I can probably run those and piggyback off the computer and power supply. That would just look so, that's probably not a necessity. And move on to the last, let's go. Okay, so I've just brought all the cables through. So I've got these big 4 stepper motor cables, but I've also got these 4 little limit switch cables. These 4 need to come into this controller box here, and these stepper motor ones need to go to the stepper motors. So what I'm going to do now is quickly get my little ferrule bootlace crimpers again, get that tool back out and strip all these, get the bootlaces on them, and then screw them down into where they got to go. And that's pretty much this section done. Now I'm going to attempt to connect in this VFD over here. So I've got this control cable coming through. That's the one that runs right up to the top of the spindle there. So this one here goes into WVU and this little one here. So I'm going to connect that into there. That's all I've got to play with. So that's pulled tight through. That's all I've got. So I really can't be wasting any cable here. All right, bit of chaos back here, but I've got my 2 fans connected to this grey wire, my other 2 fans connected to this grey wire. They both connect to the power supply, and I'm about to plug it in, switch it on, see if I get all 4 fans running at the same time. Let's do it. I don't know if you can hear that, but it's kind of revving up and revving down and revving up and revving down. I don't really know what's happening. I've got a feeling it's got something to do with maybe the power supply isn't strong enough to run them. That's interesting because this power supply said it was rated at 6 amps. This power supply is a 12 volt 6 amp. So I've gone actually over what the specs are supposed to be. Let me just turn it on again and have another listen. You might not be able to hear it on camera, but it's kind of going woo, woo, revving up, rev down, rev up, rev down. Let's close the enclosure lid, see what it sounds like. Well, I'm happy with that. It's blowing out air, it's sucking in air. I don't really care that the RPM is changing, but at this point, I think it's doing its job. All right, so I've just crimped this 4-core wire here, and this is actually going in here. I'm gonna feed it right through, and these 4 actually connect to the VFD next door, which runs the spindle. So this controller here actually, I guess you could say, it controls this spindle automatically via the software. So some CNCs I've used in the past, you've had just a manual spindle where you turn the spindle on, you turn your machine on, off it goes. This controls everything, which is pretty cool. So this wire here is gonna connect them together. Now I just got to connect up this little probe here and this red and black wire. So what I'm actually gonna do, because you need to use your probe with a CNC pretty often, and I don't want to have to open the door and close it every time I want to get the probe out. So I'm thinking of drilling a little hole just up under here and bringing it up through the table and just having the probe just sit under this area here. Whenever I need it, I'll pull it out and use it, and then I can just tuck it back under there. All right, just got a zip tie here, see if I can get it somewhere close to the, holy crap, look at that. First go. And I've just roughly measured that. That is unreal. So I'll tie the wire to that and I'll pull it up. While I'm here, I've also got to connect this probe wire into the probe signal here. So I'll quickly just connect up this. Another one of the last steps is installing this emergency stop button here. Now this is something I can't do by myself, but I'm gonna mount it for the Sparky. So when he comes in, all he's really got to do is just hook this VFD up, hook the power supplies in, and he can also run the AC wire through this emergency stop button before it goes over to the power supply. So that's how it works. The power will come through this first, then over to the power supply, which runs the whole unit. Hit this button, everything shuts off. So I'm thinking of mounting it here because if I mount it on the other side, well then that's kind of where more foot traffic is. And in the workshop I work with at my workplace, a lot of the time, not a lot of the time, sometimes these do get hit in passing by your hip or your legs or whatever. So if I put it this side here, it should be out of the way because I'm actually going to move the machine up against this wall into the corner of this room soon. So no one should be walking past this side. So I'm gonna just mount that there for the Sparky, so when he comes in, he can hook it all in and get this thing moving. All right, I just wanted to give you guys an update on the machine. So it's been a little bit of time since I last filmed the video, and there's a reason for that, and that's because I've had an electrician come in, a mate of mine has come in and he's plugged in all the AC parts to this whole machine now, so I'm super happy. Now, I didn't film any of that. You're probably wondering why didn't I film the Sparky coming in and doing it? A couple of reasons. One reason is I didn't really want to put him on camera. Second reason is because I didn't want anyone at home trying to do this stuff themselves just because they saw what he did. Because it is, I guess you could say, the dangerous part of this build. But what you can see here is he's put plugs on these 2 power supplies in this enclosure, and behind this case here, he's put a plug on there too. He's wired everything through this emergency stop button. So as soon as you hit that, kills power to everything. If you give it a twist, pops back out, power comes back on. So I'm super happy. He's put these really nice long plugs on the end of it. He's given me like a good couple meters of length so that when I push this machine back into the corner over there, I'll be able to reach my power point. So this should be all ready to turn on. I'm a little bit scared about turning it on because obviously I've spent a fair bit of time in here trying to do it all properly. And at this point, I don't really know if it's been done well, but I've gone through the manual a few times, double checked it, triple checked it, and everything looks so good so far. Okay, we're gonna stop this video here. I've finished everything I need to do on the electrical side of things. And the next video you're gonna see is gonna be part 3. It's the final part, and it's gonna be the commissioning side. So I'm gonna get the whole thing running. I'm gonna go through lubrication. I'm gonna go through software a little bit, show you how this thing runs, and get it actually doing its first cut. See you next time.